Let's talk about the rocks and minerals that we might find associated with plutons. Let's start out with the actual pluton itself, which would contain igneous rocks. So igneous rocks are simply rocks that form from a molten magma, and then the molten magma cools, and as the molten magma cools, it forms all of these different minerals that come together to form an igneous rock. The one shown here is called granite, and granite is shown in this sort of classification of igneous rocks here. It's light in color, and it's coarse grained, meaning the crystals of the individual minerals are large enough to see. And we can see there's some black things and some pink things and some grayish things in there. And if we look at those individual minerals, we see many different minerals in igneous rocks, including granite, but let's just talk about three of them. The black mineral here would be hornblende. The pink mineral here would be feldspar that we're seeing here. And this kind of glassy, sometimes a little bit greasy looking mineral here that we see here and other places here, and here. Those would all be quartz. Quartz is the most common mineral on Earth. Sometimes quartz has a chance to grow into crystals. These are quartz crystals, but that's not often the case. You would need some sort of empty space, like a crack in the rock or something like that, in order for quartz crystals to grow into it. But when they do, they can appear in all different sorts of colors. Purple, we sometimes call amethyst, and there's other colors of quartz as well. But if we just break off a piece of quartz or look at the bottom where it was broken out of the rocks here, we can kind of see it just kind of has this kind of clearish, maybe greasy-ish, grayish type color associated with it. So those are the types of rocks and minerals we would expect to see in a batholith or the intrusive igneous rock itself. However, right around the rock, there's an area where the heat from the magma chamber, when it's still a liquid magma before it cools off into a intrusive igneous rock, the liquid magma could be in contact with whatever sort of material is around here. It's called the host rock here, but any sort of material that is getting intruded into. And oftentimes these are layers of sedimentary rocks. They're just layers of rocks that are laid down, sand or silt or mud or lime. It can be laid down as a layer. And as those rocks have this magma chamber right next to them, the area kind of shown in purple here, right around the magma chamber, would actually kind of cook the rocks that are already there. And they would metamorphose those rocks into something called a metamorphic rock using just the heat from the magma chamber. No big changes in pressure involved here. It's just the heat of the magma chamber that's causing this metamorphism. And one common type of metamorphic rocks we sometimes find in this environment is one called marble. So the marble is shown on the right here. Here's just a chunk of marble here. If we cut that with a saw and polished it up, it would look more like what we might expect to see by a swimming pool or in someone's bathroom. But this is starting out as a piece of limestone, limey rock that's a sedimentary rock. It would fizz if we put a drop of acid on it. This rock here would also fizz. The marble would also fizz if we put a drop of hydrochloric acid on it. So marble sometimes just gets worn away over time because of natural acids that occur in rainwater. But what's happening here is we're starting with a limestone like a chalk. It's getting recrystallized, and as it's getting recrystallized from the heat around that magma chamber, it's turning into a new metamorphic rock that we call marble.